let's start. Before deep dive in some specific information related with what we exactly do and what our internal development, what the main idea, what we want to implement, I want to describe you Shell data project. Shell, as you know, this is one of the biggest oil company in the world. So a few years ago, Shell began one project that related with leveraging some specific fiber optic sensors within the well. So in general, it looks something like this. So this is offshore drilling platform and exploration platform. So it's not inside the well, but with well, some specific sensor fiber optic equipment. This equipment measure whole what is possible, try to track all process what's going inside the wells related with temperature, pressure, vibration, etc. And all this information is collected and sent to data sensor to then to be produced and analyzed. So why Shell do this? First, this is related with optimization. As you know, oil prices extremely go down, and all big oil and gas companies try to reduce their costs because they want to not lose part of the market, etc. And the second reason, this is try with founding some hiding area with oil, tries to rise flow rate, etc. So what about the amount of this information? So before, after first experiment, Shell collected is near 44 petabytes of information. And in general, this is just for one well, it's near 1 petabyte. If we could imagine then, in general, Shell cover more than 10,000 wells in the world. So this is near more than 10 exabytes of information. So information and challenges related with this analysis and processing of this information, this is really big. And for implementing this project, Shell inspired IBM and DreamWorks Hollywood. Yes, it's unbelievable collaboration, but to handle this information, visualize this, and at the end get such kind of pictures, they should work together. So another big company, which I think most of us maybe know, maybe not, is BP, British Petroleum. 1 year ago, they begin project which in general could be called like digitalization of all what happening inside the well across whole offshore drilling platform. This is also called, maybe one of us hear such term like industrial internet. This is potential the next big things which could be happen when all machines, equipment will be united in one big internet and could communicate with each other. Such term, I think you already know, like IoT, machine-to-machine communication, etc. And of course, this is, let's more deep dive in what mean digital oil field. So I describe you what's mean oil field. So if we look at some different part of oil fields, this is, as I talk, this is process of oil producing. At this part, you could see drilling process, some tank for storing oil with connected with pipelines, some offshore platform. And all this equipment should be united in one industrial internet network with a huge amount of sensors which should be put at each part of this equipment. And especially this is what now happens in oil and gas industry. All industry move in this area. So just in existing infrastructure, just to put sensors in each part of they work as soon as possible. Try to get benefit from. And of course, one of this questions, when we try to collect this information, what kind of technology could we use? Of course, we could just write its own software. It's not a problem. Why not? But we could look at the market and maybe try to find something existing and try to reuse in our usual daily life, especially who work with big data in practice. Good. Who knows something about Spark? Very good. So during our investigation, we generally look at all streaming technologies that present in the market. Firstly, we mostly focusing at three of these: is Spark, Flink, and Storm. But at the end, we decide to use Spark because we, in general, look at Spark at our core computing engine. So comparing of this, not only streaming is very interesting for us, and another part of streaming like batch processing and of course machine learning lib. And one of the first questions when we hear from Spark streaming, not only from Spark streaming, from different streaming system, what we want from the system. Of course, as for me, it's a key point is fault tolerance, low latency, and distributed computation, and scalability. All other, each of us could edit each own. It also could depend of type of project, what should be covered during this. And one of the main questions for streaming systems is this type of guarantee that we want to get. In general, we could get at least once, most once, and exactly once. All know what is this. We could skip this, or just I need to describe in a few words. Okay. So when we talk about it at most once, this means we, for example, could handle a record, but we could miss this record. When we're talking about at least one, each record could be handled more than once. And when we're talking about exactly once guarantee, this means that each record should be handled just only once without any duplications. So when we're talking about Spark streaming, this is, of course, this is not real time. This is near real time. In few words, this is consist from idea of streaming. Then input stream of data we split into small blocks. These blocks we organize in batches, and then these batches go through Spark processing engine, and we process this batch. For example, when we identify that we want to rise our computation after each second, that means that our batch will consist from information that would be collected during this 1 second, for example. Just in few words about Spark streaming, that available receivers. In general, when I will run practice example, some things like this stream receivers, I will talk more deeply and describe especially what they mean. So by default, some of receiver already implemented, which you could be used in production to capture some flow of information. And as usual, I think most of us, you know, as a result, you could put your information in some storages, some database, send it to dashboards, etc. What else we could talk about this? That Spark Streaming has very good high-level API for streaming operations like window, join, union, etc. Good integration with SQL, data frame, machine learning lib. And one question, this is related, we're now talking about latest version of Spark 1.6.1, about semantics. Exactly once, I'm right this exactly once, but it's not true. In general, when we're talking about version what for now available and could be used for production, Spark, this is at least once guarantee. For getting exactly once, you need to make some additional work. New version of Spark that for now available in pre-release review, Spark 2.0, which will be extend huge redevelopment, not redevelopment, but new features of Spark Streaming, which call it structured streaming. And from that information, what I read about this release, in this version of Spark, exactly once semantic should be guaranteed. How they do this, how they implement this, for now it's hard to say. Let's see when this version will go to production. So in general, how this works? I think for some part of this very known picture, but for other, any Spark application consists from driver which launch executor and whole information proceeds on this executor. Driver just only send task for doing some, for implementing some work at this executor. For Spark, for any Spark application, one of the urgent things that should be present, this is some cluster. For now available Yarn, Mesa, Spark. Also, you could run Spark in a standalone cluster, and as we know, someone in production do this. Why not? Maybe some question from. For now, okay, all clear. Okay, so. How scheduling process implemented in Spark? From which part it consists? So you just write, for example, code that doing something with your amount of information. It could be, for example, some map operation, etc. Each operation in Spark divided in transformation, in action, and actions. In Spark Streaming, divided in also transformation and output operation. Output operation in streaming and just clear Spark. It's the same with action. Before Spark could not see some action operation on output operation, nothing will happen. So based on this logic that you write, for example, in your job, maybe in some batch job or some stream job, Spark built DAX. This is direct acyclic graph. This graph is just how your transformation and action in general should done. Then this graph split it in set of stages, with each stages consisting from set of tasks. And when the stage is ready, this is submitted to task scheduler. This task scheduler just through cluster manager sends this task to worker, executors, and all work done and especially work with some data manipulation implemented at worker. So how in general looks like common Spark streaming application? So Spark, for example, imagine that we have one node for driver and, for example, at this picture, 2 nodes for executor. Spark launch at this executor a long-running task. All information goes to receiver. So one common mistake when talking with some people who start working with Spark streaming is this: imagine that data goes through driver to receiver. This is not. From driver to executor just goes only task. What exactly should be done with data? So data inputted to receivers, for example, from Kafka, or for example, it could be some RabbitMQ, or just your own custom receiver which you write. It's also possible. Inside each of this receiver, when we discuss that data organized in block and block consisted from some batch interval, which we decide when we run this task Spark streaming application, and then implement and then process on this executor, and then it could be done sent to data store or some visualization graph. So in this picture you see that data input to receiver. So what we should do to guarantee some fault tolerance. By default, when you run Spark streaming application, this means that you should have two nodes. From one node would be received data, and another node would be replicated with incoming batches for guarantee fault tolerance. So, for example, if one of the node which executed information is failed, driver automatically, you shouldn't do any work and any configuration related with this. Driver will switch to another executor and process will not stop. The main problem, if you could imagine, it's happened when driver failed. In this case, all our computation, all our received data, all blocks are lost. What we should do for this? What Spark exactly provide for this? This is checkpointing. So we could configure for our driver. Of course, if this business logic and application logic is required, we should configure our checkpointing interval. So during this interval, Spark will be automatically, for example, for some fault tolerant storage, will be save our serialized task, our configuration information, etc. So in case if our driver failed and we restart our driver will get this information from checkpointing directory and will restart this computation. Another potential problem that we could identify during debugging our application, if, for example, we lost some blocks during driver restart, how could we handle this situation? Of course, I think write-ahead lock, this is not something new, commonly used in some storage system, etc. We just also could configure this to use for our executors to save this information to some also distributed fault-tolerant system. And this is one main thing. If we configure in write-ahead lock, so we should skip this because it would be duplicating work because we already configured well and we does not need for this. So there's also one important things to remember. And yes, when we driver restart, we restart our missed block from write ahead log. So in briefly, this is about how streaming working now. Maybe some question. No. Yeah.
Out of the box, there are no fault tolerance. So if it fails, then we lose it.
This is configurable. Depends on your business needs. So, for example, if you need 100% fault tolerance, yes, you should configure write ahead log. Or maybe you could just, for example, configure 2 or 3 nodes with replicating streaming blocks. But of course, we should remember that when we configure fault tolerance, we could lose latency because additional work should be required, especially write ahead load, input-output operation, etc.
If we consume stream from Kafka, for example?
Yes, you shouldn't do this because Kafka already covered this. And in Spark streaming, with Kafka, you should not, as I told, cover some things. If, for example, you work with RabbitMQ, or for example, if you use some TCP IP socket to get this information. Answered? Okay. So in Spark, yes.
Can you tell us a few words about what kind of data it is?
Sorry?
What kind of data do you receive from wells?
Yes, of course, and it would be a practical example. I will in detail describe what we covered. So I just want to cover some information how exactly Spark works. And so in Spark 2.0, we wait for structured streaming. Of course, not all that would be already done in 2.0. Some new things will be added in 2.1, etc. And what exactly one of the main things that Spark team and Databricks want to add in new feature and a very important feature for streaming, this is real time. So maybe in this new version, Spark potentially could kill all, but we will see. So in practice, this is we discuss in general how streaming work and how it could be connect to OIL. So this is in this OIL location what I tried to discuss at the beginning of this presentation. So just in a few words, this is consist from different type of equipment. So wellhead, put it at the well, and through wellhead go not always clear oil. In mostly general situation, oil mixed with water, gas, etc. So special equipment like separator used to divide this into 2 or 3 different things. It doesn't matter. So in this case, water go to some specific reservoirs and oil go to storage. In one case, gas go and just flare, but in future it would be changed. And what we want to do from this, we want to gather information because in each part of this equipment put a sensor here, 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 here. This is big amount of sensors. For example, we now look. Oil guys called wellhead Christmas tree because this look like Christmas tree. So, for example, how we could automate just only one part of equipment from oil location. We're now talking about only wellhead. So we just put it sensors and different parts of wellheads and we want to control, as I told, for example, pressure, temperature, different. We also could control from here oil flow rate. And this is prototype implemented with ZigBee technology. I think someone who work with IoT already know about this. So this is also one of the benefits of this. We could inject the sensors in already working oil location. Doesn't depend when this location, when this wellhead present. It could be offshore and onshore. And we could, this potential, maybe in future, this system could work without any participation of engineer. So during day, this information collected and sent it to our cloud, and when this in this cloud we should do some magic with our data. So one of the popular, not commonly used, but very popular protocol called MQTT in IoT. In oil and gas industry, very big amount of articles that call that MQTT could reduce old SCADA formats that now one of the common used in whole, not only oil and gas industry, but in general this is going going with very low speed. So this is just would be simple prototype example that not related with production, but I think in general you could understand what especially happen and what we could monitor, etc. So I will just run a small example. So we just emulating wellhead information and some readings and send this to our streaming system. So let's look like. So what engineer could look at the engineers at each real day work. So as I told, this also location which consists, for example, some wellheads, some meters which oil goes through this meter. And for example, we could monitor some specific reading from different wellheads, some gas meters, etc. This is just one prototype what engineer could see. In this example, we just monitor pressure, temperature in two different, it would be 4 different sensors which injected in two sensors in wellhead and 2 sensors in gas meter. I just want to show you. And we, for example, will look at code. So as one moment. So as I told, we create here 2 streams. So when we create stream, Spark will create entity called receiver. Each receiver not united, how it's better say, each receiver, how it's better say in English. Each receiver maybe, okay, let's try to think in another way. So when we create stream, each stream return for us the stream. This is some abstract terms, and in general means some continuous of RDD. As you know, one of the common and one of the atom unit in Spark, in general Spark, this is RDD. This is, we could imagine that this is one big collection that goes through whole of our cluster, so unlimited. So each receiver united to each D stream united with specific receiver. For our implementation, we use already implemented receiver which goes with Spark streaming. This is MQTT receiver, and we just union these two stream in one stream to simplify our calculations. As you remember, I told you that, for example, this operation, if, for example, we remove here, reduce, so nothing will happen, because this is action inside output operation for each RDD in the stream trigger whole our computation. So if we just remove this, nothing will happen. We just only receive information and that's all. This is also one important things to remember. What else I want to add about this potential problems on some mistake would be happen, that I add a comment here. So this is execution happening in drivers. So for example, if you at this place create, for example, imagine some connection to database and try to use this connection here, you will receive serialization error, because this code will be executed at receiver side, inside node in that executor. So for this case, if you want to, for example, send some information to database, you should here at that place, potentially, you could create a connection and send this information. But this also would be not best solution, because inside each of this record, inside of this maybe I don't know, it could be 10, hundreds records. You will create each time connections to database is also not good. In this case, you, for example, make partitioning to split your RDD to some blocks, and before go through this whole partition, you could use this connection, and inside each of this computation, just reuse this connection. Maybe some question about this code? All ok? Okay, so let's look in some, I want to add two important things which you want to, when you will debug Spark streaming application, what's better to look. Firstly, two urgent parameters. This is scheduling delay and processing time. Better if your scheduling delay, it would be near 0 each time. And processing time, it would be good if some average meaning of this parameter would be not greater than your batch interval. So if you see that your scheduling delay or processing time is begin grow, this means that something happened unusual, unstable in your streaming application. And list of active batches, for now this is empty. This is good. If, for example, a list of these batches is very big, this means that, for example, your receiver could not handle and not have enough time to handle input information. This is a feature was added in Spark, as I remember, 1.5.1, called back pressure. So if, for example, your receiver could not handle incoming flow rate. This is just Spark automatically put this task, all this task in queue, and then when you, for example, it could be potential some blocking operation. When this will gone, Spark will take this task from each task from queue and just send for processing. But of course, we remember that this queue is not unlimited, and sometime your application could be dropped. So this is one of the key 2 points for remember. So in our case, if we look at our schedule delay, it's about 0. This is good. And processing time, we put our interval for 7 seconds, so processing time is very low, so it's also very good. And here you could see 2 our receivers that now working in system. So what else interesting for debugging our your Spark streaming application and each streaming, and maybe just in general Spark application. So in this case, in our example, as you can see, we run to our receiver. So 2 long-running task is, I'm sorry, long-running job task. It would be the similar work. It's okay, and we see that amount of already implemented our jobs. So each job can consist of set of tasks which was completed at our executors. So if, for example, you want to debug and look exactly what happened at each job, so this here is our 2 long-running job, and for example, you could open some of this job, see especially DAG visualization. So that's all. Questions? Question could be in Russia. So if you want to contact, to participate in some discussion, to share knowledge, we open, please.